Hi, I'm Ryan Nickel, CTO at DSA Ocean, and today I want to talk about a new feature in ProteusDS that helps with the design of moorings for things like wave measurement buoy systems in oceanographic moorings. So these kinds of moorings tend to have fairly small size buoys, and the loads in the moorings are not very big. So when you're trying to design a mooring and get feedback and make a better design, we look for other metrics to give feedback. And one of these is a new parameter that we've added to our post-processing tools called a wave check factor. This was inspired by some ideas we got from our friends at CDIP at Scripps in California, but it's a pretty straightforward idea. The general idea of this wave check factor is that it's a calculated value based on a ratio of the standard deviation of velocities in the z direction to the standard deviation of the square of the sums of the horizontal plane velocities of the buoy. So what we're kind of looking for is getting a sense of the ratio of like how circular is the motion of the buoy in the wave parameters. We found that the closer this value is to a value of 1, the more that buoy is following the wave sort of orbital pattern. And that applies really well for sinusoidal waves, and it applies really well generally for wave spectrums as well. Where it won't apply as well is if you've got a really shallow water case, and then there's already kind of an elliptical kind of wave particle motion. But for the most case, like this works pretty well across a wide range of water depths. So let's look at what we've got. Two examples here. On the left side here, we have the default SOFAR spotter buoy template. So the SOFAR spotter buoy, well-known buoy for measuring waves. It's kind of small, which is nothing wrong with that, of course. It makes it great for following water waves. But it means that the mooring loads are really low generally. So we don't tend to design these based on line loads, based on line strength. We look for other parameters. And the wave check factor is now a piece of feedback you can get from this mooring report in ProteusDS. So if we look at this case, what we're looking at here is a scenario in 5-meter significant wave height, 9-second peak period wave spectrum. And you kind of see the wave following the water surface pretty well. And, you know, of course, you can look at tensions and things like that. But generally, the tensions are pretty darn low, you know, less than a couple hundred newtons. You know, like we're not talking about a lot of loads, generally speaking. So that's fine. And then we have our other mooring. So I made a different version here where I just added a second midwater float. There's one midwater float, 12-inch sort of trawl float in the middle of this mooring. It helps with compliance, the give and take of the mooring to ride those ocean waves. And I added a second float here. It just so happens it turns out to go to the water surface, and it makes kind of sort of almost like a tether to the SOFAR buoy. Now, there's other facets to the design of these systems, and in fact, one important one is submergence rate, which is another feature that we have, but we're just focusing on the wave check factor today. What I want to know from this is, like, what does the wave check factor tell us about how well that buoy is following the water surface? And now you can see that as one of the outputs. So we'll just pause this. Remember, it's the ratio of the standard deviation of the vertical velocity to the horizontal plane velocities, right? So if we look at the oceanographic mooring report, so this is an Excel report that's automatically made with a button push in ProteusDS simulation toolbox, and we scroll down here. Under submergence probes, you'll see this wave measurement check factor. So sort of not exactly anything to do with submergence. I mean, kind of is if it's not following the water surface very well, but you can see for the mooring with one float, we got a factor of 1.03. Another story you see here about the submergence rate, this is the percentage of time it's below the water, like it's kind of submerging a little bit. So there's two totally different things, both kind of affect wave quality, but something to keep in mind. Now, let's look at the report for the wave check factor for this other mooring. So I've got the mooring file here. Let's open it up, and we'll scroll down, and we see a wave check factor of 0.86. So it's actually like not quite as good as our other case over here. Now, what does that mean? Why is it like that? I think maybe what's happening is that we're getting a bit of like sort of dynamic, you know, loads laterally from this sort of tether here. The submergence rate is way better, but you know, it's just not quite as good at generally following the water surface. So is that a good thing? Is that a bad thing? You got to use your judgment. You got to factor in all the details of how the mooring works, but it's another piece of useful feedback that can guide you in terms of like which mooring design is better than another. Yeah, and it's a great piece of information you can get. So this is produced as a single value calculated at the end of a simulation in the Oceanographic report tool. That's all I wanted to highlight for now. Thanks for watching.